Welcome back to Maths with Mrs. J. We've had an introductory lesson about complex numbers. And we've learnt about the fact that complex numbers really encompass all real numbers as well, but with the addition that here we can have an imaginary part. The imaginary part, or I, is defined as being the square root of -1. Addition and subtraction of our complex numbers that are in Cartesian form is super easy. It's just like adding and subtracting like terms in algebra. Multiplication and division is also relatively simple with a few little tricks in there that we learn from our surds topic. Let's go through a few examples and I'll show you how it all works. All right, let's take this first example. This is just like a normal expansion situation where you're going to get your 4 terms. All right, so let's go through that normal process. So we're going to get 2 times 5, which is 10, plus 2 times 2i, which is 4i, plus negative 3i times 5, which is minus 15i, minus 3i times 2i, which is minus 6i squared. Now, just bear in mind, I squared is -1. So -6 times I squared is +6. Let's actually put that in as an extra step at this stage because we're new to this. So that's the same as +6. Now we're at the point where we can just add up our real parts. So we get 10 plus 6, which is 16. And collect our imaginary parts. We've got 4i minus 15i, which is -11i. So that's a relatively simple process as long as you understand how to expand and as long as you just remember the fact that I squared is -1. All right, let's do another expansion again, just using our expansion techniques, but this one happens to be a perfect square, so let's use our rule for that. So we're going to get 4 squared minus 2 times 4 times 5i plus 5i all squared. Okay, that's just our a minus b all squared is a squared minus 2ab plus b squared. You should be fairly good at expanding that by now. Okay, 4 squared is 16. Minus 2 times 4 times 5i. 2 4s are 8 times 5 is 40, so minus 40i. Let's have a look at this. We're going to get plus 25i squared. Now again, we need to remember that I squared is -1. So this is the same thing as subtracting 25 because I squared is -1. So again, just collecting up our real parts and our imaginary parts. 16 minus 25 is -9 and our imaginary part is minus 40i. Okay. Okay, multiplication was relatively simple. We just used our expansion and then we used the fact that I squared was -1. Division is somewhat reminiscent of our surds topic when we were rationalising the denominator. You may or may not recall, if we had something like this in our surds topic, I might have said to you, rationalise 2 over 3 plus root 5. Rationalise the denominator. What did I do to rationalise the denominator? Well, I multiplied by an appropriate version of 1, which is perfectly okay to always multiply something by. That's just 1. But I rigged it so that then we can use our difference of 2 squares to get rid of any surds in the denominator. So the numerator will end up being 6 minus 2 root 5. Just expanding out. Normally you'd take an extra step to do that. Your denominator will be 9 minus 5, which is 4. And you can actually divide the whole lot by 2. So you get 3 minus root 5 on 2. We're going to use a very similar strategy here in that we're going to multiply by, and it's actually called the complex conjugate. So what do you think the complex conjugate to 7 plus 2i would be? Well, how about 7 minus 2i? Now let's see what happens. We're going to show all our working here. So we're going to get 6 plus I, 7 minus 2i in our numerator. In our denominator, we've rigged it so that we're going to get 7 squared minus 4i squared. All right, that's your a squared minus your b squared. Okay, expanding, so we're going to get 6 times 7, which is 42, minus 12i, plus 7i, minus 2i squared, all over 49. Now, if you're subtracting 4i squared, you're really adding 4. Same thing here. If you're subtracting 2i squared, you're really adding 2. So we've got, for our real part, 44. For our imaginary part, minus 19i, all over 53. And clearly nothing's going to simplify there. You can split it up like that if you want to, but it's not necessary. It's perfectly fine to leave it like that. Okay, what would our conjugate complex number be here? Well, same thing that we did with our previous one. We're going to rig it so that with difference of 2 squares expansion, we're no longer going to have an imaginary part in our denominator. So let's do this. So this will be 4 squared minus 9i squared. The numerator, 3 times 4 is 12. 3 times 3i is 9i. Minus 8i, minus 6i squared, all over 16 plus 9. Okay, now that will be adding 6, so we'll get 18 plus I, all over 25. And there you go.